All right, guys, we just talked about the Pythagorean theorem, and the Pythagorean theorem says if a triangle is a right triangle, then a squared plus b squared equals c squared. So we just got done talking about Pythagorean theorem, but now we need to also learn about the converse of the Pythagorean theorem. And it says if a squared plus b squared equals c squared, then the triangle is a right triangle. So you can use the Pythagorean theorem to prove whether it is a right triangle or not. So here's kind of just an image down here. We have a right triangle. We know a squared plus b squared equals c squared. If they give you side lengths of a triangle and they ask you, is it a right triangle? What you're going to do is you're going to plug it in. So you're going to plug it into a squared plus b squared equals c squared, and you're going to calculate it to see if they're equal. If Pythagorean theorem works, then it is a right triangle, like over here. If the Pythagorean theorem doesn't work, then it is not a right triangle. So that's what we're going to look at today. Is 48, 55, 73 a Pythagorean triple? Now, Pythagorean triple is just some fancy math words for saying, is it a right triangle? So Pythagorean triple just means that the three values work in the Pythagorean theorem. In other words, is it a right triangle? So if we try our Pythagorean theorem, a squared plus b squared equals c squared, I always plug them in least to greatest. Technically, it doesn't have to be least to greatest. A and b can be interchangeable, but c has to be the biggest size. But for me, if I plug them in least to greatest every time, then I know that I won't make a mistake with my hypotenuse or my c value. So I'm going to plug them in least to greatest, and I'm just going to do some calculator work to see if it works out. So I'm going to do 48 squared plus 55 squared. You can type that in your calculator in one step, or you can type it in separately, but there's no letters in there, so we could just type it all in together. So if you wanted to do 48 squared, you could write that down. And then you could do, I already forgot what it was, 55 squared. And write that down. And then you could add those two numbers together. You could do it that way. For me, since there's no letters, I like to type it all in one step. So for me, I would do 48 squared plus 55 squared, and I would do it all there in one step, and you'll see that you get the same answer. So if you want to square each number and write them down and then add them together, you can, or if you want to just type it all in one step, you can do that as well. So I tend to type it in one step. So this side is 5,329. And then I'm going to see what 73 squared is. I have so many things open here. Oops. So then I'm going to go over here and I'm going to type in 73 squared. And it is also 5,329. Since both of these are equal, in other words, since the Pythagorean theorem worked, we can answer two things. First of all, we can say, yes, it is a Pythagorean triple. And we can also say, yes, oops, I'm abbreviating here. Yes, it is a right triangle. So by using the Pythagorean theorem, we can test out a couple things and prove that it is a right triangle. Now, if we had gotten to a situation where this said like 5,000 equals 5,329, those would not be equal, and so that would not be a Pythagorean triple, and it would not be a right triangle. All right, which of the following numbers completes the Pythagorean triple? Oh, wait, let me go back to this first one. If it gives you a whole bunch of these as multiple choice options and asks you which one works, you're just going to have to try each option until you see which one is equal, which one works. Okay, so on to this one. We want to know what completes the Pythagorean triple. Okay, so we know Pythagorean theorem is a squared plus b squared equals c squared. Oops. And if it's a Pythagorean triple, then we know this formula has to work. So we're just going to plug in our values least to greatest. 7 squared plus 24 squared equals, we don't know squared, right? There's a blank, we don't know it. So then we're going to do some solving. Now, since there's no letter on this side, if there was a letter, you couldn't type it in the calculator, but since there's no letter, I'm going to type all of that in one step. So let me clear out all this mess. So I'm going to come over here and I'm going to say 7 squared plus 24 squared, and that equals 625. Now 625 equals c squared, but it doesn't want us to figure out what the square is. It wants us to figure out the missing length. So we need to get rid of the square. And the opposite of squaring is square rooting. So we would square root both sides because the square and square root cancels, leaving you with just c. And then we could go to Desmos and we could type in the square root of 625, and that equals 25. So our missing length here to make it a Pythagorean triple is 25. A triangle has the side lengths 28 centimeters, 41 centimeters, and 53 centimeters. Is the triangle a right triangle? Anytime you want to know if it's a right triangle, you are going to test the Pythagorean theorem. If the Pythagorean theorem works, then it is a right triangle. If it doesn't work, then it's not a right triangle. So I plugged my values in from least to greatest, and now I'm going to go ahead and solve. Since there's no letters on this side, I can type that all in one step. So I'm going to do 28 squared plus 41 squared. That's 2,465. And now I'm going to type in 53 squared. See what that equals. That's 2,809. Wait, 809. 2,465 does not equal 2,809. Those are not the same. Because the Pythagorean theorem does not work, we know that this is not a right triangle. So we can say that it is not a right triangle because the Pythagorean theorem does not work. Emily drew the following triangle. Does such a triangle exist? So we have side lengths 10, 15, and 20, and we want to know if it actually makes a right triangle. It has this box here, and this box means that it's a right angle. So we're going to prove to see whether or not this is actually a right triangle. And the way that we prove it is using the Pythagorean theorem. If it is truly a right triangle, then the Pythagorean theorem must work. If the Pythagorean theorem does not work, we know that it is not a right triangle. So let's plug it into our formula from least to greatest. So 10 squared plus 15 squared equals 20 squared. Since there's no letters on this side, I can go ahead and type it all in my calculator. 10 squared plus 15 squared. So 325 on this side. What that is. Oh, it changed colors. That was weird. And then 20 squared. I'm going to go ahead and type that in. Oops, not on that one. Oh my goodness, what is it doing? 20 squared is 400. 325 does not equal 400. So this is not a right triangle because the Pythagorean theorem did not work. So let's look at our answer choices. Yes, it is possible. No, it's not. No, it is not possible to create a right triangle with the side length shown. Or no, it is not possible to create a triangle with the side length shown. What we're proving with the Pythagorean theorem is right triangles. This is what we're proving with the Pythagorean theorem. We're not proving that it can be a triangle. We're proving that it has to be a right triangle. And just as a side note, if she had just drawn this triangle and she hadn't put the right angle there, then you could try to prove that it was just a regular triangle. But because she put the right angle there, we're trying to prove that it is a right triangle, and it is not a right triangle. Okay, that's it. Good luck on this converse of the Pythagorean theorem work.